How's it going? It's Brian with LDTI, Leak Detection Training Institute. Today we've got a service line leak. It's basically a leak from the meter pit to the home. The way they know they have a leak is by all the water out here. It's been showing up, and the city came out and told them they had a leak. And what they've already done is the isolation phase. So usually what I want to know is, first, do we have a leak? I can look at the meter and see the meter spinning. So there's a good chance that this water showing up in the street is not from the meter back to the city main. City has already verified that. Second thing I'll do is go into the home, turn off a valve in the house, and then come back and check the meter. Because I want to know, is this leaking in the house, at a toilet, at a sink, at a faucet, anywhere in the house, or is it leaking between the meter and the home? So we shut off the water in the house, came out, checked the meter. It's still flowing. We're losing about 3/4 of a gallon a minute, and it's going to be somewhere under the ground through here, probably pretty close to here, because we have water in the hole in the meter pit and a hole that the customer already dug. So the first thing I'm going to do is connect a noise correlator to the system. It's an AC200 by Sniffing, and what it's going to do is going to listen to the pipe and triangulate between the two microphones in close proximity to where the leak is. So you see we put a microphone on the pipe that leads down to the house, and then we'll put another microphone at the shutoff in the house. And the Sniffing AC200 is a fantastic device. The only information you really have to give it is the size, type, and distance of the pipe. Noise correlation is fantastic. It's really, really helpful. Usually what I want are 5 pieces of information. I want to know location of the pipe, which we're going to locate here in a minute to verify that the city was correct in their locates. And it's copper pipe, so it should be really easy to locate. I want to use a noise correlator to identify where the leak is. Then I'm going to use ground miking to listen to the water spraying out of the hole in the pipe where the noise correlator said the leak was. Then lastly, I'm going to push tracer gas into the system and flush the water out. And then I'm going to listen to the sound of that tracer gas coming out in the area where the tracer gas is. So by the time I'm done, I know where the pipe is. The noise correlator's told me where the leak is. I've got the sound of the water spraying out of the pipe. I've got tracer gas coming out of the ground, and I've got the sound of the bubbles from the tracer gas coming out of the pipe into wet soil. If all 5 of those agree, I feel very, very confident in putting a mark on the ground. Not every job is going to allow us to use all 5. So sometimes we can only get away with 2 or 3. Sometimes we have a pipe that the noise correlator doesn't work so great on, or we can't locate the pipe because it's non-conductive. So there's times where we have to work off of maybe 2 pieces of information or 3. And if that's the case, we have to be very discerning with that information and focus a lot more attention on the sound of the leak, and does that sound like the amount of volume we're losing out of the pipe. Again, we're losing 3/4 of a gallon per minute. And we'll get started by correlating and then locating first. "55 feet. So we're using the Sniffing C-Core phone AC200, and we've put a microphone at the meter pit and a microphone at the main 3/4 copper line coming into the house. And usually what you're looking for is a perfect signature is that these 5 dots are completely solid and full. It means we've got a really crystal clear sound. And this device gives you a distance from each microphone. So microphone 1 is out there at the meter pit. Microphone 2 is inside the house here. We've got a total distance of 55 feet. And right now it's saying the leak is 7.7 feet from microphone 1. So it's towards us from that meter. And when you see the correlator lock onto a location like this and it's no longer doing other correlations and jumping around, that's a very, very good sign. So the next step we're going to do is go out there and listen to the ground directly above 7.7 feet and see if that sound is something we want to go after. So the noise correlator has said that we have a leak 7.7 feet from our microphone there. I have to anticipate some piping going down because these pipes are usually 3 to 5 feet out here. So the pipe's going down, rolling back this way. So right now I'm just going to say there's a window between there and here that the leak exists. We still have a fantastic correlation. It's not moving at all off of that initial locate. And the cool thing about the Sniffing AC200 is I could put the headphones on and I can put microphone 1 in one ear and microphone 2 in the other ear, or I could put them both in one ear. But it's really neat because you can listen to that and actually hear it and go, yeah, okay, leak is definitely louder on this side. Always remember, if you can't hear the leak, neither can the noise correlator. So you never really want to break it out unless you can hear the leak. And if you can't hear the leak, it's probably so small you're going to have to resort to tracer gas and try and pinpoint it that way. The noise correlator told me there's a leak basically about from where the measuring reel is to the meter pit. And I'm trying to listen, but I'm challenged by several things. We've got planes going overhead. It's kind of windy out here. The wind is fluctuating. I've got cars driving by, and I've got a guy who's running a generator less than 100 feet away. So I've got a pretty challenging environment when it comes to listening. I'm not hearing the sound I want to hear to say that's a leak sound. And the same sound I hear right here where the pipe is, I can put the microphone 10 feet away and hear the exact same sound. So that's why it's really important not to focus on where you think the leak is and hear something and say, there's the leak. It's really important to listen over there and go, okay, the sound I'm hearing is just ambient sound. Because we've got, the generator, we've got wind, we've got all kinds of stuff going on right now. It doesn't seem like a very busy street, but there's stuff going on. So I know that when I switch mediums and start pushing tracer gas, two things are really going to help me out. One is I'm going to see a tracer gas signature. That's a really definitive for me. When I have tracer gas coming out of a hole in the pipe, coming to the surface, I know there's a leak there. And then we're going to get to listen to that. So right now I'm listening for a sound that's similar to the wind. It's going to be a or a ch, and it sounds a lot like that car going by. However, if I switch the medium over to compressed air or tracer gas, it's going to give me a bubbling sound or a spitting, sputtering, spraying sound. It's very similar to other leaks that I've had in swimming pools and stuff like that. We're always trying to mix that air water to get just the right sound we're going after. It's also important to make sure when you're listening to a sound that you have the power to make that sound go away by turning the water off or turning off your tracer gas. So if you get down to the point where you're like, this has got to be the leak, you can listen to it, get it in your head exactly what it sounds like, and then turn off the catalyst, which is your pressure, bleed the pressure off the system, and come back and listen in the exact same spot and see if the sound you were hearing goes away. If it goes away, that was your leak you were listening to, because you're the one creating that catalyst for that sound. If you turn off the pressure and bleed all the pressure out, really important, bleed the pressure out, and you come back and listen in the same spot, and you hear the same sound that you thought was a leak, it's probably not a leak, it's probably just ambient sound in the ground. It's also important to look around and say, okay, we've got a yellow mark there, which is natural gas. It's cold. They're running natural gas right now. I know there's natural gas flowing through that pipe. So I know that I might be picking up that sound over there as well, which is the natural gas flowing through the pipe. So always look around at your environment and try and evaluate, is there anything here that's going to throw me off by listening to this sound? Okay, so I'm hooking up tracer gas to the house. First thing I want to make sure is when I connect to the hose bib that we don't have a frost-proof hose bib or any kind of backflow preventer on here. I don't see a vacuum breaker, I don't see anything like that, so I think I could probably push tracer gas in here. Other places that are good to push tracer gas are supply lines underneath kitchen sinks. I could have undone the 3/8 compression on the supply line going up the kitchen faucet, and I've got a hose I can connect to that, or washing machine boxes. We know this is cold water line. It's never a good idea to push tracer gas into a hot water system because if you've got an electric water heater and you have your elements embedded in water, they're safe. But if we fill your water heater full of tracer gas, that element's going to sit in air and they will pop. So if you've ever been a service plumber, you know not to have air in a tank. Always make sure you've got your water tank full of water and you're pushing water out of the system. There's no air in before you turn the power onto it. Also, it's not a hot water heater. If you had hot water, you wouldn't want to heat it. Sorry, plumber joke. So basically I have a system here that I'm introducing gas here. So I've got my tracer gas coming from the truck. I've got a valve. I've got a regulator that I can regulate how much pressure I'm pushing in the system. Check valve. This system I can actually add water to it if I want to. And then this goes out to wherever I'm testing. So in this instance, this is going out to the house. And then I've got two separate gauges. This is a 0 to 30, just in case I'm working in 1 to 2 or 3 pound increments. And then this gauge over here shows me bigger numbers up to 160. So what I did is I turned the system on, I rode my red needle over here. We're operating at about 50 PSI on this system. Now I'm going to go turn off the meter pit, main water coming in, and then come over back here and watch and see how fast this is dropping. So what I've done here is I'm pushing tracer gas at the house back towards the meter. I turned this union nut off, backed it off enough to where I'm getting water out of here. This is the process of flushing the line out. So I'm getting all the water out of the line so that I can get tracer gas to the line faster. Otherwise, I'm sitting here waiting for 3/4 of a gallon per minute to go out. I could be waiting for 20 or 30 minutes. It's not that I'm not impatient. I've got other things to do with my life, and I don't want to charge a customer for hours that I don't need to be here. So I'm going to push this until I see tracer gas coming out of there and spraying, and then I'm going to tighten it back down. Do not back that union off all the way because there's a washer that will drop to the bottom of the meter pit. These meter pits out here are about 5 feet deep. You will not get the washer back. So always have a good handful of those washers in your truck so that you can replace it. I rarely take the meters out unless I absolutely have to, because I know the city's not very fond of that. And if I do take the meters out, I always replace those washers with brand new ones, just to help the city out so they don't have to do it in the future. So that's the sound we're going after. That means that we've got all the water out of the system and it's charged with tracer gas. And then we'll just crank that back down. Again, I didn't back it off the threads, I just backed it off a few turns. So it's really easy to go back down tight and get it shut off. So now that I've run the correlator, we've got a line locate. I tried to listen to the leak. I really couldn't hear much of anything to the sound of the water coming out of the pipe because we've got so many ancillary sounds, including traffic, a generator, wind, some airplanes, just stuff that's kind of annoying. I don't need to hear the leak. I would prefer that. So like I talked about earlier, we can change the medium and start listening to the sound of bubbles or tracer gas coming out of the hole in the pipe. So next thing I'm going to do is I've introduced tracer gas. I've cracked the union nipple and bled all the water out of the line. I've charged the line completely with tracer gas, and now I'm going to start sniffing. I want to start up here at the house. I know that when I bled all the water out of the line, I filled that meter pit with tracer gas. We've got a nice breeze, so it's cleansing the surface. But if I started at the meter pit, I'm probably going to get tracer gas right away because there's probably still some residual sitting in the meter pit. So I'm going to start up here at the house and do a sweep from here towards the meter pit. I'm picking up fumes from the generator, and I know that because I'm off the ground. If there's a hole in the pipe somewhere here, you're not going to pick up fumes 3 feet off the ground. So I'm getting 2.5 parts per million, and I bet if we went right up to that generator and started sniffing, we'd start spiking. So always anticipate that. Again, we've got a leak that's 3/4 of a gallon per minute, so I should be getting a pretty decent gas signature. So I'm not going to be able to start at 0.0, which is what I prefer. So we're just going to start checking this line out from across here and see if we see anything. Really small leaks, it's important to go slow because you're looking for a very small gas leak. If we're looking for a big leak, I can move a little bit faster. I'm looking for quite a bit of gas flowing out of here. So again, 3/4 of a gallon per minute should give me a pretty good sized gas signature. And we're starting to go up. This is great. I'm at 18 parts per million right now, 20. And climbing. 36. Okay, right here it's starting to go up. Let's move that flag over a bit. Still climbing, and I want to find the point where the gas starts to dissipate and go away. That's going to be the outside of our scent cone, which is right about here. So if you look at the visual, these flags are the outside of our scent cone. We have a scent cone. That's basically, imagine this pipe is 4 or 5 feet deep. and the gas is going to come up and form a cone like this. So these outside edges are what you're seeing here and here. That means that the leak is most likely between here and here. This is an older home, which means that when they backfilled this system, they probably used the native soil. You've always got to think about that. Newer lines in the Denver area have got squeegee or gravel, usually pea gravel or sand, 6 inches to a foot above and below. That will allow that tracer gas to travel through the gravel and then come to the surface. So I'm always accounting for how old is the house and how was it built. Since we have natural grade, backfilled, no gravel, no squeegee, and I've got a scent cone that starts right there and ends right there, my leak is going to be in this space here. I'm positive about that. And we are up to 0.25%. So the Severin Variotech Forces Detracer gas is one of the best sniffing devices in the market. It's super accurate, has never given me a false positive, and I would not want to do leak detection without it. It almost feels like I'm cheating when I'm doing leak detection. So right now we're at 0.1%, 0.15. That's a fantastic gas signature, and that does reflect. See how it's dropping there? So I moved over a little bit. That does reflect a 3/4 gallon per minute loss. If I were looking for 3/4 gallon per minute, I was only getting maybe 5 parts per million. That's not a good enough signature for me to say it's time to dig here. But when I see that kind of gas signature, it's fantastic. So the next step is to listen in this area and see if you can hear that bubbling, spitting, sputtering sound. Okay, so as you just heard, when I was listening to that leak across these different points, just like the scent cone we get from the tracer gas is going to come out of the hole in the pipe, come through 4 or 5 feet of dirt and make a cone like this. And I marked the edges of that scent cone with these 2 flags. So I know the leak is within this space here. When we're listening for sound, I'm not just listening for the sound of the leak, I'm listening to the quality of the sound. And the quality of sound is very important. So when I first started listening here, I could hear it. I could hear the bubbling sound. And as we graduated towards the center, it got louder and more clear and more precise. And then as I went further away, it dissipated almost completely. So the best quality sound is right here. I've already put a blue X on the ground, identifying that mark. And then the other part of it is you've got to think about what you're listening to. We've got a 3/4 gallon a minute leak. We've got a pipe that's been dumping water for quite a while. So we've got a lot of wet dirt all around this hole in the pipe. And as we start to dump air out of it, or tracer gas in this case, you're going to get a bubbling sound. And a lot of time that water will create a cavern in there, and that cavern will really amplify the sound a lot. So we've got the sound of the bubbling here, but it sounds kind of like far away because we've got so much dirt between us and the sound. And as you get towards the center, it spikes right here. This is the best quality sound. It's not just the loudest, it sounds almost like you can listen to the sound of the bubbles kicking out and fill in that space, that little cavern inside there, and it amplifies it even more. And then as we go further away, it goes away. So I have a scent cone as well as a sound cone, where you've got the outside edges of where the sound, where you can actually hear it, and then right in the middle you can hear the best quality sound. I highly suggest when you get into leak detection and you start to get onto leaks and you start listening to them, take your time and listen to them. Really listen to all the little intricate parts of it so that you can further identify that in the future. And the best thing you can do is label those. Is it spitting? Is it sputtering? Is it spraying? Is it bubbling? Does it sound like rolling thunder? Actually label what you're hearing in your mind so you can revert back to that in the future. So basically today we've got the location of the pipe, we've got tracer gas coming out, scent cone right here, best quality tracer gas signature is right here at 0.25%, and then I've got the best quality sound right here with a sound cone that dissipates here and here, and the spike is right here. So I feel very confident marking this, knowing they're going to dig this and find the leak.